So let's start our class today. So today we're gonna go over some questions that were in homework 5 and PS 5 and 6. So let's start with the handwritten problem first. In PS 5 there is a problem 3. So you may check your questions in the website. So first question is to find the disorder of attribute 1, okay? So disorder D is defined as minus LT log 2 L over T minus P log 2 T over P. Okay, so T here is just total of P plus L. So this is an equation for computing the disorder of attribute 1. And this P here means the person, and L here means location. So person plus location is all the levels we have. So adding the number of person and the location will give us total. Okay. So let's start with the attribute 1. So in attribute 1, there is a yes in attribute 1, right? Yes or and no for the attribute 1. So for the yes term for the attribute 1, for the yes term, there's a total of 6 yeses in the first attribute. And out of 6 yeses, there are 3 persons and 3 locations. So which means there are a total of 6 yeses in attribute 1, and there's 3 locations, and log 2 of 3, 6, and minus, and there's total of 3 person in attribute 1, so you can write like this, okay? This will give us 1, and D, no. So in the first attribute, there are only 3 no's, okay? And among 3 no's, there is only 1 location, okay? So 3, 1, log 2, 3, 1. And out of 3 no's, there are 2 persons, so we can write 3, 2, log 2, 3. And if you use your calculator to compute this equation, then you will be able to get 0.9183. So now we've calculated the disorder of attribute 1, okay? Now, let's go to the second problem, which we have to compute the disorder of attribute 2. Now, the equation for the disorder is same as before. So it's just you have to just plug in the right number of total and location and person. Okay. So in the attribute 2, there are a total of 4 yeses and 5 no's. So let's start with yes term first. Okay. So D yes dash is among the yes terms, like 4 yes terms, right? There are 4 locations and 0 person, okay? Which means there's 4 locations, okay, but 0 locations. Oh, 0 persons? Yeah, 0 persons, okay? So we can write this as like this, which is just 0. And for the no term, there are a total of 5 no terms in attribute 2. So among these 5 terms, there are no locations, so 0. So log 2, 0, 5, minus, and there are a total of 5 persons in the no term, right? So if you check the problem, in the attribute term, there's a yes and no, so 4 yeses and 5 no's. And among 5 no's, there's no location. So no location, and all the no's are persons. So we can write like this, okay? Which is also equal to 0. So now In problem 3, the problem asks if attribute 1 is better or 2 is better to divide our term. Obviously, the second attribute is better because, as you can see, if the second attribute says yes, then it is location. And if the second attribute says no, then it is person. However, in order to prove that the attribute 2 is better, we use the quality of test, okay? Now, as you have seen the lecture, in the lecture, the quality of test, Q test, is defined as sigma of D sets. This sets means both yes and no, right? And times number of samples in sets. And the total number of samples in all sets, okay? So this equation basically means that the sets, we have two sets, yes sets and no sets. And among the total sets, which is 9 of sets, how many are yes or how many are no, right? This term means, okay? So we have all of 9 sets. And if we want to calculate the quality of test Q1 of attribute 1, then we can write these sets. Let's start with yes term, okay? The yes term was 1, okay? So 1 times, now number of samples in all sets, 9, right? 9. And how many were yes? 6, okay? 6 were yes, like this, okay? Then plus, now second set is no, and no term, disorder term is given right here, and 0.9183 times. Now there are a total of 3 no sets among 9 sets, right? So 3 over 9. So Q1, using your calculator, which is equal to 0.973, okay? How about the Q2? Q2 is quite simple, right? Because all the D terms, the disorder terms are 0, so the quality of test will be just 0. Now Q2 is 0 and Q1 is 0.973. As you can see in the lecture note, the smaller the quality of test, the better the feature. So Q1 is bigger than Q2. So we can say that attribute 2 is better than attribute 1. So is there any question about this problem? So basically this problem just explains how the decision tree is working. Yeah. Any questions? Okay then. Let's go to the coding problems then. So the first problem is about kNN, which is k nearest neighbor. And in this problem, you need to write your own function for kNN regressor. So the data was given like this. Okay. So I'm gonna just explain details about the answer. So now data is just like here. And this is x term and then y term. So this code basically starts by defining the x's, which is x points first, okay? So you're gonna say, it just says that between there's negative 30 and 30, you're gonna just set some xp's, and we're gonna find the corresponding yp, so that we can just make the kNN regressor work, okay? So let's start just by looking at this code. So we define xp and we define yp as a blank because we just want to find how this x's, xp's, yp gonna work when we just look at the k nearest neighbor. So the code starts from by just computing the distance between the points this is just all points, and there's xp1. So this basically means that there's a points like this, okay? And from here, we set xp here, okay? Let's just consider our xp starts from here. Then, in this code, we just distance. This dist means distance. So we just compute all the distance between all points, all the data points, okay? And then we just sort them, okay? Which means we're going to sort from the smallest to biggest like this, okay? So this means that if we set xp over here and we just compute all the distances from every point, then we can just sort it out according to the distance. Then we will know the nearest neighbor by just looking at the index of this point, okay? So after sorting out, we need to choose the k nearest neighbor. However, in this code, we choose only one k nearest neighbor, which means the first one, which is the closest one. So basically, when we choose this xp, we're going to look around the nearest neighbors, and we're going to sort the distance like an array. Then we're going to just select the closest one as our xp's yp, which means if xp has the closest point right here, and this xp was about 2, then this yp was 2, y was 2, then this xp point xp will get also yp is equal to 2. So this is basically looking around the nearest neighbor and find our point, and use the point's y level as its y level, as a xp's y, okay? So this code is very unnecessary to memorize because all these codes are encoded in the scikit-learn package, so I'm not gonna require you to know this, okay? So since we just set k nearest neighbor as just 1, so we just look at only a single point nearest to that to the xp. So the xp will start from -30, so start from here. And if we start from here, the nearest neighbor, the closest point will be this point, right? Then the -30 will just follow whatever the value the x point over here has. Okay, it's same. Since all the xp's follow the y value of one nearest neighbor, which is the point that is closest to the xp, so this curve is quite overfitting. Okay. So in order to avoid the overfitting, instead of just looking at a single nearest point, we just change it to 10. Okay, which means we look at now 10 nearest neighbor among these xp. So if you find 10 nearest neighboring points by sorting out and selecting the 10 points with the closest distance, we're going to just use the yp. Yp value will be just average of these all 10 points. So average value of all y's of 10 points, okay? So this is just definition of kNN regressor. You just find 10 or 15 nearest neighboring points, and we're going to just use the average value of that 10 or 15 points as its y level, okay? Now, if you see the result, it's much better, right? Now, if you select xp over here, you're going to just follow the average value of the 10 nearest value. So as you can see, previously this -30 point was close to -15. However, because we are just using the average value of the 10 nearest points for the x is -30, we get like bigger than -15. So this is just a kNN regressor with own code, but I don't think this is necessary to memorize or know, because kNN is basically all written in scikit-learn package as a function, so you don't need to know. And the second is kNN classification. Now kNN classification is same. Okay, so looking at this points, this data, so same. Yep. So as you can see, we're just doing the same thing. So in this problem, we just defined xp like in the one-axis term. However, because we have like a 2D, two-dimensional plot over there, so we're gonna just use 2 instead of 1. Okay, because because we're using 2 axes, we're gonna just build a grid. Okay. So by the meaning of building grids means that we're gonna just pinpoint a point here, and we're gonna decide the label of this point, and this point, this point, this point, this point, this point, and so on. So we're gonna just predict the label of each point on the grid with the kNN classification. So after we're building a grid, we're gonna just stack it as we did for XP as an XP. And this is basically saying we're just calculating the distance between these XP points and all other points on this drawing. Okay, so if we set our XP point like this, then the kNN algorithm will just find all the distance to the points, and we're gonna just find the k nearest neighbor. So if you set k nearest neighbor as 1, then our xp was here. Then the k was the first nearest neighbor will be this point, right? Then this point, the imaginary point here, will follow the label of this k nearest neighbor. And if we extend our label to 10 or 15 points, then we will just find 10 or 15 nearest neighboring points and use the label that is the most common among these neighborhoods. Okay. So as I explained, this is just way of getting the distance between the XP point and all other points. And after we sorting the distances, we will be able to find the top highest data set, which means the distance is very close to the point we selected. And then we're gonna just choose the label, which is the most common in the group of nearest neighbor. So this basically means that if the point like this, and this is label 0, label 1 as a black, and yeah. So the black stones are label 1 and white stones are label 0. And if we select XP over here, then we're gonna just look at 6 nearest neighbor, and the 6 nearest neighbor will be these points. And among these points, the most common label is just label 0, right? It's just following this, okay? So we will count all the labels for the k nearest neighbor, and we're going to use the label that is most common among this k nearest neighbor. Again, I think this problem is quite unnecessary because the kNN classifier is well defined in scikit-learn package, so you don't need to write your own code. Okay. So as I said before, we just choose k nearest neighbor, and this time I set k as 1, which means I'm gonna just look at the single nearest neighbor and use the label of that point as my XP's label. So the result says, yeah, quite overfitting, right? So our primary target was to classify this circle among other points. However, because we just set k nearest neighbor as 1, which means if we set a xp point over here, then we will just use the closest neighbor's label. And there's a black point over here. So this region just used the nearest label, which was 1. Okay. So rest of things are same. So it is basically overfitting because it is using the label of a single point that is closest to that xp. Okay. So next we just increase the number of selection by 10. Okay. Which means that we're going to just look at, instead of looking just a single point to find the label, we're going to just look at 10 points, 10 nearest points to find the label of a certain point, decide the label of certain points. So now it is better, right? So in the previous one, we just look at the closest point. So this region over here was considered as the label of black because the black point is here, and you're going to just look at a single point. However, because we're just looking at 10 points nearest to the XP over here, imaginary point over here, that's why this region is just classified as label 0. Because there's only one label 1, black here, and rest of the points are just 0. So this is quite good when they are outliers. Okay, so this was the kNN classification, and the second part is a k-means clustering. Okay, so this is just plot, so I'm gonna skip. And if you want to find the centroid points of the data we got, then you just have to use the numpy mean of a data 1, okay? So data 1 has some array of x and y. So for the centroid in x-axis, we just find the numpy mean of 0. So first column. So this is just finding the centroid of our data. So I'm gonna just skip it. So since we knew that our data has 4 types, and we knew exactly the centroid of these 4 types of data, we was able to find these central points. However, let's consider a situation where these all labels are not given, which means that we don't know if this point was from data 1 or not. This whole data was given, but we want to cluster these whole points into 4 groups. Then we use the k-means clustering, okay? So this is very simple. There's k-means, which is defined in the scikit-learn package and easy to use. And since we kind of like this number of cluster is kind of cheating because we already knew that there are 4 data, so we just use the number of clusters as 4. So I'm going to discuss what if we don't know how many clusters are existing for k-means later. But let's just say we just pick a right number of 4 clusters. And we just fit all this data that is stacked. So now the data is considered as single data of x, okay, here. And we just fit this x into k-means. And the k-means will give a label, okay? Will give a label of 0, 1, 2, and 3. So if there are 4 labels for each point, the k-means will give 4 labels. For example, like this region, this region, this region, this region. The k-means clustering will just cluster the points as a region base, okay? So if the point is in the first region, then its label will be just 0. Label will be 1, 2, and 3, okay? This is just a method of giving labels. And this code is to find the centroid of each cluster. So the k-means label is equal to 0. We're going to just find all the points index where the k-means label is equal to 0 and find this mean of x-axis points. So which means if you find groups of points that is classified as 0 by k-means clustering, then we can just we can find the centroid of this cluster by computing the average value of the all x-axis in these groups. Okay, the rest are same, so I'm gonna just skip it. Okay, so as you can see, it's quite different from what we expected. We expected some kind of this kind of graph, but it's quite different. But this looks quite understandable, right? The k-means clustering just finds the clusters that all the points belongs to. So this was quite okay, interesting to see. And since we knew there were 4 clusters before we've done our k-means clustering, we just use n cluster, number of cluster is equal to 4. However, in order to decide this number of cluster well, we need to draw elbow curve. Elbow curve is just basically so this elbow curve. So this looks like an elbow, so we call this elbow curve. And in this elbow curve, we can just write select the number of cluster that corresponds to this elbow point. Okay. So this elbow point can be characterized by there's a non-linear decrease in the coast, and there's a linear decrease in the coast. Okay. So this will decrease dramatically and will slowly, linearly decrease if the number of clusters increase, okay? So we're going to select the changing point where it decreased non-linearly and change to linear decrease. Okay, we're going to select this point as number of cluster. So in order to find out this curve, we can just use the coast score of the k-means. Which means if we select k as 1, there's only 1 cluster, then we will make a score by using this k-means algorithm where we define number of clusters as 1. And we're going to just do that for all k-means for 10 clusters. And if you look at the result, so as I said, the score decreased dramatically. However, it starts to decrease linearly from here. So we're going to just set this point, which is elbow point, as our primary number of cluster. So this is quite heavy method to find out number of cluster because we just compute all the scores for using number of clusters 1, 2, 3, or 10, but it is very necessary if you don't know how many clusters are in your data. So basically, this clustering method is used for unsupervised learning, which means that the labels were not given and any information about label was not given. So you're given a data, but you don't know how many labels are there in the data. Then the k-means clustering is a very good tool to use because it will find out not exact value but some approximate value about how many labels are existing and which points are very close to which level. Okay. So basically, this is used when this can be explained with a simple example. Okay. Let's say we have MNIST data set, which is picture of number 0 and number 1. Okay. Let's say there's a 0, 1, 2. Since we knew that there are 3 clusters, we can just say number of clusters are 3. However, if we didn't know the number of clusters, then this elbow point will be a good choice. This elbow point will say 3, and this k-mean clustering will cluster these 3 points. And in order to check the real level of these 3 groups, you just have to open a centroid part. You just open it. Then this open part will be like 1. Then we can just say that all the points in this cluster is level 1. And if you check this point, and it was number 0, then we can say that all points in this cluster is level 0, and so on. So this is very useful tool when we don't know the levels of the data points. So now, fourth problem is k-means clustering on image colors. Okay, so basically this image has some noises. The color is not that clear, so we're gonna use the k-means clustering to make this color very good. Okay, so if you go on a code, this is quite simple. So you're just finding out the shape of the image, and we just reshape the image into this kind of form. So basically, the image is a 2-dimensional data, and each pixel has 3 color value, RGB, okay? So if we consider this image has a size of 25 pixel and 25 pixel, then the total image data will be in size of 25 times 25 times 3, okay? Because each pixel has 3 values of RGB, okay? Now, since we want to use the k-means clustering, we're gonna just use reshaping. So by reshaping this kind of term, you can just write 625 times 3, right? We just multiply this forward term into 625 and 3. So now the data here was a 2D array where each pixel has 3 RGB. Now we reshape this into like a single array, like a vector, where each point has 3 values RGB and 625 points. And we're going to cluster these 625 points according to these 3 color values, RGB, okay? Now we used k equals 6, and I decided 6 as randomly, and the clustering shows quite well, right? There's much clearer images given than before. So using this k-means algorithm is quite simple, so I'm not going to go over it. It's just we're just using the scikit-learn package, and also this clustered, where numpy levels is equal to I, we're going to just use the color value of a cluster centers I, which means this means that so we cluster, we will so let's say if we use k as 2, and there's 2 groups of points, or 3 groups of, let's use k equals 3. So according to the color value of each pixel, we just make the cluster, okay? And each point in the cluster has some kind of little bit different colors because of the noise that we have given to the image. However, instead of using each pixel's color value, we're gonna just use the color that corresponds to center of the cluster, okay? Therefore, all the noises that were given to these nearing points, the clustered points, will be directly given as the centroid's color value. Okay? Therefore, we can just reduce the noise to a single color. Okay? This is basically all the codes that you need to do for setting the color of these pixels into the color of the centroid pixel. Okay? So therefore, we can just we can just get a clear image without any noise on the colors. But what if we use ks equals to 2? Okay, then we will cluster all the points into the 2 colors, and this is the result that we can see. So basically, the code over there, over k equals 2, will just cluster all the points, all the pixel points, into 2 groups. This is basically like, if you can see here, the clustered points are a group of dark points and bright points, right? If we use k is equal to 2, okay? And if you want another color here, and we now get some kind of orange color included in this painting, okay? So by like giving more and more clusters, we can just make another group of points, group of colors. So this k-means clustering that groups colors with similar pixel values are like an ancient method to make image segmentation. So have you guys heard about image segmentation? So image segmentation is basically there's a computer vision task where if there's a like human over here, then the computer algorithm will segment this human as blue color, okay? This is just image segmentation technique. So this k-means clustering was a basic, like ancient starting point of this kind of image segmentation. So second question is to decide the right number of cluster. And as I said before, you can just use the k-means.score in order to find this elbow curve and find the elbow point. And here, although I used k is equal to 6 above, I think the k is equal to 4 is better than k is equal to 6, because after the k equals to 4, the points are just meaningless, right? So what if we use k equals to 4? Yep. So all the blue points are gone, but I think this painting is good enough without any color noises. Okay. Now the last question. Last question is to change this image into black and white. So black and white is just simple. We have 2 colors, black and white. So we just use k equals to 2. And these following terms are basically equal to what we have done. We have just changed to 2 by 2 array with 3 pixel values into a vector which contain each point containing 3 point RGB values, okay? So this is same, I'm gonna skip. And we've set k equals 2 because we want to change this image into 2 color, black and white, okay? So with this k-means clustering code, we just cluster all pixels into 2 groups. However, the 2 groups value are not known, okay? So we need to check each point belongs to what color, okay? So after this k-means clustering, we just cluster into, we just define a color, okay? This color means if the label of a k-means label, if there's 2 points, we just use the 2 points, right? 2 clusters. We just built 2 clusters, and if the k-means label, k-means clustering just gives a random label. K-means gives us 0, and k-means gives us 1. If the k-means gives a value of 0, then the color will be given as 0. So in the above example, we use the color of the central. However, instead of using the color of central, this time we're gonna define new color by color index, which is this. Okay. So if we set like this, then all the points here will belongs to the color, that color of 0, okay? Color of 0 was 255, so it will belongs to black. And if you came in as 1, then these points will belong to color is equal to 0. So let's look at these. So if you print out, so we just set all the all the points that belongs to k-means level of 0 as white points. However, as you can see in the result, it was opposite. Because k-means gives random label to the cluster's points, we are not clearly know which label belongs to black or which label belongs to white. So we just want to change this color by 255 over here and 0. Yeah, then we will get what we want. So basically this k-means clustering just gives us a random label to each cluster. So if you want to find out what these clusters belongs to, you just print the center points and check if the center point really belongs to what you have thought or not, okay? Any questions? Because we're about to finish our class.